Today we are moving on to section 1.5, and that is talking about compound inequalities. So we already talked a little bit about graphing inequalities and how the signs and everything work when we were doing absolute values, but we're going back a step and we're going to do some compound now. So we're going to have two different situations. We're going to have and or inequalities. So and equalities, that happens when things are overlapping. So this stuff that's highlighted here, that means it's important. So you need to write that down in your notes. So and means overlapping, and that means that we are finding all the values that make both inequalities true. And then this one's not highlighted or anything, but it's still important. So typically or inequalities go in opposite directions, although sometimes some of the solutions may overlap. But for or inequalities, that means all the values that make one or the other true. And then at the bottom here, we've got some important signs and things like that. So all of this needs to be written down in your notes. These are hints. So if you see less than or greater than, that means you're going to have an open circle. If you have less than or equal to, greater than or equal to, you're going to have closed. And then for shading, it kind of depends what side the variable is on, but these four scenarios up top, that means that happens when you shade right, and the four scenarios on the bottom, that means you're going to shade left. So you've really got to pay close attention to your solutions about open or closed and shading right or left. Okay, first example, we have -7 times 3x minus 7 plus 21x is less than or equal to 50. So this isn't a compound inequality, it's just one inequality here, but I need to solve it. And then whenever we get our solution, then it needs to be graphed on a number line. So I have a set of parentheses with the number out front, which means I need to distribute. So -7 times 3x is -21x. -7 times -7 is +49. Bring everything else down. Okay, now on the left-hand side, I've got two terms that I can combine. -21x plus 21x. Well, those are just going to cancel. I'm left with 49 is less than or equal to 50. 49 is less than or equal to 50. So we need to decide, is that a true statement or a false statement? Well, 49 is less than 50, so that means it is true, which means it's all real numbers, which means I have a number line, and I'm going to shade the entire thing. Now, we talked about that a little bit when we were doing absolute value inequalities. So if you've got a true statement, there's no variable left, that means the entire line is shaded. So this would be my solution to this first inequality. Okay, next we have -6a is less than or equal to 18, and 5 minus 3a is greater than 2. So I've got two inequalities here. It's a compound inequality with the word and separating them. So the word and is going to get brought down and is going to go in between my two solutions. And other than that, I just need to solve. So I'm going to divide both sides by -6. Bring down my a. Now when we divide or multiply by a negative number, the inequality sign needs to flip. So it's going to be a is greater than or equal to 18 divided by -6 is -3. Bring down the word and. Now I need to solve the second one as well. This is just like if we had an equal sign instead of an inequality sign. It doesn't change the way that we solve. So I'm going to start by subtracting 5 from both sides. 2 minus 5 is -3. Now, just because I subtracted 5 doesn't mean my inequality sign flips. We only flip it if we divide or multiply by a negative number. So I'm going to divide by -3. If you were thinking at that point when I said that out loud that you need to flip your inequality sign, that is right. -3 divided by -3 is 1. So this is my answer. But then I also need to have a number line. So part of your answer is the solution. Part of the answer is your number line and your graphing. So I need to put both of these numbers on my graph. The smaller number needs to go to the left, so -3. The bigger number needs to go to the right. The negative 3, it says greater than or equal to, so that means it needs to be a closed circle. The 1 is just less than, so it's going to be open. And it says A is greater than or equal to negative 3. So that means this shading is going to go this way. For A is less than 1, that means it's going to go this way. So I need to shade where those two overlap, which is in between. Okay, next example, I have 2x is greater than 3 minus x, or 2x is less than x minus 1. So I've got two inequalities here. I have this one, and they're separated by the word or. So when I'm solving the first one, I'm going to start by adding x to both sides so that I can get those together. 2x plus 1x is 3x. Bring down the word or. And then I need to divide by 3. 3 divided by 3 is 1. Bring down the word or. And then for this one, I'm going to start and I'm going to subtract x from both sides. 2x minus x is x. And then I'm just left with x is less than negative 3. I'm going to go ahead and bring that down so it's kind of lined up with my other answer. But that is my solution. Now I need to graph this on a number line. Remember, I need to find my smaller number and put that to the left, so that would be negative 3. And 1 is larger, so it needs to go over to the right. Now, does the circle on negative 3 need to be open or closed? It should be open because it's not equal to. What about on 1? Same thing, it should also be open. For x is less than negative 3, that means my shading needs to go this way. For x is greater than 1, that means my shading needs to go that way. And they're not going to overlap, which is fine because it's an or inequality. So I'm just going to go ahead and draw my shading on the number line. Okay, next example, I have negative 1 is less than negative 6x plus 11 is less than 1. So this one looks a little bit different. It's all squished together. It's the same thing. It's just a compound inequality. But I'm going to go ahead and separate them so that we aren't solving all off the same problem. So I'm going to go from my outside number to my next inequality sign. So I'm going to rewrite that. Write the word and, because since these are written together, that means it's automatically an and inequality. Then to find my other one, I'm going to go from the right-hand side and go to my other inequality sign, and I'm going to rewrite that. So now I have two separate inequalities that I need to solve. I'm going to be carrying down the word and the whole time. So I'm going to start and I'm going to subtract 11 from both sides. Negative 1 minus 11 is negative 12. And then I need to divide both sides by negative 6. Remember, when you divide by a negative sign, the sign needs to flip. Negative 12 divided by negative 6 is 2. Bring down the word and. Now I need to solve this one. I'm going to subtract 11 from both sides. 1 minus 11 is negative 10. Now divide both sides by negative 6. Flip the inequality sign since I divided by a negative number. Negative 10 divided by negative 6 is not going to divide into a whole number, so I just need to reduce it. That is going to give me positive 5 over 3. That's my first part of my answer, and now I need to graph it. Okay, I need to decide is 2 or 5/3 bigger. Well, 5/3 is smaller, so that's going to go to the left, and then 2 will go to the right. Both of my inequality signs are not equal to, so they are going to have open circles. This first one, it says x is less than 2, so that means my shading would go this way. For 5/3, it says x is greater than 5/3, so that means my shading would go this direction. This is an and inequality, so I only care about where they overlap, so that would be in between. Okay, last example. I have negative 4x minus 2 is greater than or equal to 10, and 1 minus x is less than 0. So this is an and inequality. I'm going to be bringing that word down. I'm just going to start with the first one. I'm going to add 2 to both sides. Negative 4x is greater than or equal to 12. And divide by negative 4. X is less than or equal to, I had to flip my sign since I divided by a negative number, negative 3. Bring down the word and. For the second one, I'm going to start and I'm going to subtract 1 from both sides. 0 minus 1 is negative 1. Now, a lot of times students want to stop here, but we don't want negative x, we want positive x. So I need to divide both sides by negative 1. When I do that, I have to flip my inequality sign. Negative 1 divided by negative 1 is positive 1. These are my two solutions. Now I need to graph my answer on a number line. Negative 3 is smaller. 1 is larger. For on negative 3, that is going to be a closed circle. And on positive 1, it's going to be an open circle. X is less than negative 3, so that means I'm going to shade to the left. X is greater than 1, which means I'm going to shade to the right. This is an and inequality, which means we are only interested in where the solutions overlap. But if I'm looking at my graph, those are never going to touch. So that means this is no solution, and we should have an empty number line.